Alright, so I'm going to show you how to annotate a simple gene here. There's two things you're going to need. You need to go to Google and go to Mega Software. It's going to be Mega X. It should be the first link, and this is all stuff that you can do. Have that downloaded, and the other software you'll be using will be something called Expossi Translate. This will be the other piece of technology you will need in order to do the DNA and RNA sequence. So the first thing I'm going to show you how to do is to put your assembly file into Omega. So the way to do that is go to your Omega, go to Align, go to Edit, Build Alignment, create a new alignment, hit OK, make sure you select DNA, and then from Edit, go Insert Sequence from File. This is where you're going to take your assembly file, which you should have already downloaded to your computer, and open. And so now you have your full assembly file into Omega. I would recommend saving this because you'll probably open and close it a lot, but this is what you're going to have to do. Now the fun thing we can do with this is if I wanted to go to any base pair, let's say I want to go to base pair 10,000, put in 1,000, so base pair 10,000, it's a C. So basically it's easy for you to jump around, and this will be important later. Now the next thing you'll need to do to annotate is you'll need to go into your FAST file. So go to your Mitos results, open up the file, and look for the FAST file. These will have all your genes in order. To do an annotation, you need to use this and put it into Expossi. So an easy gene to translate is NAD6. So I'm going to copy here, copy it, and then I will paste it into Expossi. In Expossi, you want to make sure you're on verbose. It's forward and reverse. And also it's in invertebrate mitochondria. Now we're going to translate. Alright, so this is a lot of stuff, but basically you'll never really use reading frames 3 to 5. You'll always use reading frames 5 to 3. Reading frame 1 is telling me that I'm reading from the first base pair, so I go ATT, ATT. Reading frame 2 is basically getting rid of this base and saying TTA, TTA. And reading frame 3 is starting from the third, so TAT, TAC. You'll want to, when you get to your final annotation, work with only the first reading frame, but you can use all three when you're trying to figure stuff out. So when we look at the reading frames, what we see is here we have a highlighted region with no stop codon, meaning that it's not completely finished. Then we'll have to find that stop codon, but we do see that this is a solid gene. So now I normally recommend finding your stop codon first. So we're first going to go back to the FAST file, and we're going to see that NAD6 ended at 8,912. So I'm going to open up my Omega, go to 8,913. Not 12, because if I put in 12, what I've done is I'm copying a base that doesn't need to be there. So this is the end of the gene. This is the start of something new. And my goal is to find a stop codon. So I'm going to go this way, and I know that TAA is a normal stop codon. So I'm going to add that into Expossi. Normally what you want to do is you want to leave a space just to make sure you're not like pasting in a whole nother gene on accident when it actually copied. So let's translate. And now we have a stop codon. Now, stop codons are either TAA, TAG, or TGA for the most basic genes. The other thing you need to be aware of, if I had an extra base here like a T, it's going to read me as a stop codon, but it's not going to tell me there's an extra letter. So this is where you're going to make sure that when you look to the end, the last 3 bases are going to be that stop codon. Now, the best way to check for this would be to see how this is a TAA, delete 1, and translate, and notice that that stop codon went away. So I know that this is actually my stop codon. Now, the other thing you want to make sure you're aware of is what position did I find this at. So the new position is going to be 8921 to the end of this gene. Now we're going to go back to this FAST file, and it starts at 8430. So I'm going to go back into Omega, go to 8429. Again, the same reasoning is we don't want to add this base in since we've already added it. And we're going to just go backwards until the previous gene. So we're going to go back to 8403. There are two ways to look for the methionines. And then there's A and G. There's two ways to look for the methionines. When you are looking for where the start of a gene is, you want to first minimize the amount of space between each of the mitochondrial DNA because mitochondrial DNA is super compact. The other way, and so when you hit the next gene, you can occasionally go into the interlapping space, but that's rare. And the other way you can do it is you can look for when the next stop codon is before the start codon. So in this scenario, there's not going to be a stop codon before I hit the next gene. So I'm going to run all the way backwards to the next gene. So I translated it here. So what we see is there's another methionine here. So this methionine right here is that methionine that we originally know. I believe this methionine is one of these two where we originally started, but we went back further into the gene to minimize space because mitochondrial DNA is super compact. So what we're going to do is we're going to cut 2, 3, 6, 9, 12 bases. 6, 9, 12. Should be an ATA. Two start codons that you normally see will be ATGs and ATAs. So here we have a methionine to stop. So now we know that this is the position of my gene. So let's go back into Omega, and we know, and this is the starting position. So the starting position of this gene is 84115. So just a little recap for the start codons. The two different ways is to go back until you hit the next gene. Or you go back and then hope you hit a stop codon, and then after you hit that stop codon, you look to the closest methionine to that stop codon. In this case, there was none, so we just went back to the next gene. So now that we've done this, we're going to copy, and we're going to open up a text pad, and we're going to go New File. I'm going to hit Control V. Then you want to label it. So this is NAD6. And it's an ATA start and a TAA stop. So I just do that just so I know that's there. The one thing I will say is you'll want to actually save this onto your desktop or in a folder, because if you don't, you won't be able to find it again. So NAD6. So this is how you annotate a basic gene on the positive strand. There are some other things you'll learn as you go through, but I hope you have a good day.